Okie dokie. So what we got here is a problem where a plane is flying from Houston to San Francisco. And when you fly to the West Coast, you encounter headwinds, which means the wind is blowing into your face or into the fuselage, which is going to slow the plane down. It's also going to kind of blow it off course a little bit. Now, the direction of the plane is described going to San Francisco, and that's 40 degrees north of west. The plane's speed is 425 miles per hour. Now, the plane is going to slow down a little bit because of the wind blowing into the plane. So the wind's going to slow down the plane a little bit. And so that's true. When you go from the East Coast to the West Coast, it takes you longer because the wind slows you down. So it might take you 6 hours to go from New York to San Francisco, but only about 4 hours and 45 minutes, maybe 5 hours to go from San Francisco to New York because of the effect of the wind. So what we want to do is assume the average wind speed is 40 miles per hour, determine the resultant speed of the plane. What's the actual speed going to be due to the effect of the wind slowing down the plane? And then, since the wind is going to blow us a little off course, we're going to find out how far off course the plane is going to be. And we're going to do that based upon degrees to compare to the 45. Okay. So what we're going to do first is we're going to model the plane with a vector, and we're going to model the wind with a vector, and then add the two vectors to get the resultant. The magnitude of the resultant is going to be the speed of the plane. And then we'll do the arctangent like we did, if you remember when we found the angle. We're going to do the arctangent to get the angle of the resultant, which is going to be either a little more or a little less than 45 degrees. Okie dokie. All right, so here I drew a little bit of a picture. So I'm going to use vector P to represent the plane and vector W to represent the wind. Okay, so the wind is blowing to the east. The plane is going up and to the left. Okay, and then the bearing that we're given is north of west. So I put that verbally on the file I shared with you. If you want to write this with the bearing notation, so coming from the west to going north. And this would be the proper there. This is more appropriate. Okay, now just to review that again, remember with bearings, the first letter is the line you're starting from, and the second letter is which direction you go. So since it starts with W, that means from the west, we're going to go 45 degrees north. Okay, so that's what that means again. Okay. All right, well, the resultant is going to be in this direction. So that's the resultant of the plane being affected by the wind. So it's going to go a little bit more northerly than San Francisco. Okay. So the first thing we want to do to solve this problem is to get the vectors that represent W and P. Okay. So when we get the vector for P, it's kind of like a right triangle. This is a 45-degree angle, and the magnitude is like the hypotenuse. All right, so notice the x component, the horizontal, is going to be based upon the adjacent to the angle. And the y component, the vertical, is going to be based upon sine of the angle. So our p vector equals 425 cosine 45. 45 and 425 sine 45. Okay, now we're going to worry about which is negative and which is positive in a moment. But let's first get the two basic vectors and then go back and figure out, okay, which one should we make negative? Okay, well, the wind vector is only pointing horizontally, pointing to the right. So there's no up or down, there's no vertical component. So the wind vector is 40, 0. Okay. All right, now let's go back to the plane vector. Let's decide how we make this positive or negative. So in general, if you're going up or to the right, that's positive. If you're going down or to the left, that's negative. Okay, so as the plane goes west and north, it's going to go to the left and up. All right, so it's going to be negative for the x component. So that's negative. Okay, so now we've gotten everything we need to solve the problem. We set up the basic vectors and then went back and made sure that we have the positive and negatives correctly. Now, for the wind vector, it's only pointing horizontally to the right, so that should stay positive. There's no up or down dimension to the wind vector, so the y, the vertical component is 0. Okay, so we want the resultant, and then once we get the resultant, we'll be able to get the actual angle of travel that the plane is going due to the effect of the wind. And we'll be able to get the resultant and find the actual plane's velocity, speed, after it was slowed down a little bit by the wind. Okay, so the resultant is going to be equal to these two vectors being added. Okay, so then that means all right, and here, so you should get and then we find the resultant of that will be rather than writing the numbers again, right, just square root of the x component squared plus the y component squared. Again, this is related to the Pythagorean theorem. And so you should get, when you do that calculation, you should get 397.722. Okay, so notice the speed of the planes reduced a little bit because the wind is slowing it down since the wind is coming into the face, right? Into the fuselage of the plane. So about, what's that? 20, a little more than 27 miles slower. Okay, so that's our resultant. And now what we want to do is find the actual angle made with the horizontal. We're trying to do a 45-degree angle to get directly to San Francisco, but the wind is blowing us a little off course. So the actual angle with the resultant is probably a little bit bigger. It's going to blow us a little more northerly, towards Northern California. So we just want this angle. Now when we do that, we don't really care about the negative here because we're just trying to find the angle of this triangle. We need the negative when we do vectors because direction matters. But once we get the numbers and we're just trying to find the angle in this triangle, we don't really care about the negative. So then we just use our tangent of the y divided by the x. Oh yeah, because it's cosine 45. Since it's, I don't know why. Tripping. All right, when you do that, you should get 49.078. So about 4 degrees more. So we're going about 4 degrees off course. So we'll wind up in Eureka. Right? But we don't want to go to Eureka. We want to go to San Francisco, man. What the heck? I mean, nothing wrong with Eureka. Okay, so notice when you subtract 45, that's about 4 degrees off course. So what good is that? What can we do with this? Well, we're going to have to compensate for the fact that the wind is blowing us off course. So it's blowing us off course 4 degrees above. So let's go 4 degrees below 45 to correct for that. So to correct for the fact that the wind would blow us off course if we try to go directly to San Francisco, let's instead fly at a 41 degree angle. And that way the wind will blow us, but it'll blow us in the direction towards San Francisco. That's how this is useful.